Welcome to Science and Sleep, where cosmic stories drift gently like a breath, and each planet is a whisper in the night. Whether you are listening in the quiet space of your room or amidst a city still echoing with late traffic, let your mind drift along with the rhythm of the stars. Here we are in no hurry, only curiosity, slow reflections, and a bit of the light of knowledge guiding through the endless darkness. Tonight, as you gently close your eyes and let your imagination soar beyond the orbit, we will traverse the cold winds of Neptune, heading toward the distant frontier of the solar system, where ice and darkness meet in the quiet music of the universe. Before beginning our journey, I would really like to know, where are you listening from? A cozy room, a small balcony under the starry sky, or somewhere within a dream? Leave a comment, because every line of your sharing is a little star illuminating the sky of the Science and Sleep channel. And if you love slow voyages through space and time, don't forget to like, subscribe, and turn on notifications so you won't miss any journey. Stay until the end of this video, because I believe that, even if you fall asleep midway, you will still wake up with a slightly broader mind, as if the universe whispered something that only you could hear. When the light of the sun is nothing more than a faint glow amid the eternal night, where temperatures are so low that even atoms seem hesitant to move, the Kuiper belt is the place where time almost stands still. Space here is no longer measured by distance, but by memory. Every ice block, every rock, is a fragment left over from history. The first dust grains that once orbited a young star that had just ignited 4.6 billion years ago. If the solar system were a gigantic book, then the Kuiper belt would be the first pages frozen, never turned. The objects here, small but persistent, still retain their chemical composition from the dawn of the universe. They are living evidence of how the initial chaos gradually organized into order, how gravity patiently bound dust grains together into worlds. At this distance, the sun is no longer the blazing fire of life, but a distant star, weak as the memory of a dream. Its light takes more than 6 hours to cross the cold void and reach the silent ice blocks that orbit it. There, day and night lose meaning, for even when light arrives, it is too weak to warm anything. Icy worlds like Pluto, Haumea, Makemake, Eris are not just lonely dwarf planets but ancient witnesses. Their surfaces are chemical records preserving traces of methane, nitrogen, carbon monoxide, volatile compounds that have long since vanished in the inner solar system. Every crack, every frozen plain tells the story of millions of years of upheaval, when comets collided, when the rare sunlight caused the ice to expand and crack, and when darkness returned, hiding everything in silence. In this distant place, movement is rare but never stops. Objects in the Kuiper belt slowly orbit the sun along elongated ellipses lasting hundreds of years. Pluto, for example, takes 248 Earth years to complete a single orbit. During that time, it passes through regions of space where sunlight is so weak that the surface temperature drops to around 230 degrees Celsius. At that level, everything is frozen, not just gases, but almost time itself. Yet, it is precisely this stillness that is a treasure for astronomers, because here, matter is not disturbed, not melted, not destroyed. It is like a cosmic fossil museum where we can see the raw materials from which the solar system was once formed. When NASA's New Horizons spacecraft flew past Pluto in 2015, the first images sent back to Earth astonished the world. Instead of a lifeless ice block, Pluto appeared with serene nitrogen plains, towering mountains of water ice as high as the Himalayas, and even cracks that could be signs of geological activity. This shows that even in the seemingly deadest places, the universe quietly moves, breathes, and lives. Further out, smaller objects, tens of thousands of mini-planets never named, continue to quietly orbit. Some exist in pairs, locked in binary orbits like ancient dancers, forever revolving around each other in the slow dance of gravity. Each such pair is a question science has yet to answer. How did they form, and why have they remained intact through billions of years of upheaval? At the far edge of the Kuiper belt, where light nearly disappears, scientists believe there may still be an unseen world. Planet 9, the hypothetical ninth planet. Although no one has seen it, gravitational traces suggest that a massive object might exist, silently pulling smaller celestial bodies into unusual orbits. If it truly exists, then our solar system is still incomplete. The story continues to be written in the darkness. The Kuiper belt not only helps us understand the past, but also illuminates the future. For from this region, strange comets sometimes cross the solar system, carrying organic molecules, the building blocks of life, toward Earth. Some scientists believe that these icy visitors may have sown the first seeds of life on the blue planet. If so, then you and I, all of us, carry within us a piece of memory from the distant Kuiper. So when we gaze at the night sky, perhaps somewhere at the edge of the light, those ancient ice grains continue to quietly orbit, reflecting our gaze, a reminder that the past is never lost. It just drifts a little farther away. And when you let your mind drift along an imaginary orbit, think of this. Each planet, each ice fragment, is a story yet untold. A story of patience, of time, and of how the universe creates beauty from stillness. In our hurried world, the Kuiper belt is the only place where slowness is not procrastination, but the essence of existence. The cold classical bodies in the Kuiper belt are the most silent creatures of the solar system. They have never been disturbed, never strongly affected by the chaotic migrations of the giant planets. For billions of years, they have quietly drifted along their nearly circular orbits with very little inclination relative to the ecliptic plane, like icy monks keeping the vows of primordial times. Their surfaces, if one day we ever touch them, are likely among the most pristine places remaining, where water ice, methane, and ammonia have solidified since the dawn of the solar system. In contrast, the hot objects are the untamed travelers. Their orbits tilt steeply, sometimes exceeding 30 degrees relative to the ecliptic plane. They rush through space along elongated, distorted paths, like scars left behind from Neptune's chaotic migration. Each hot body is a witness to the collisions, struggles, and ejections that occurred during the time when the giant planets had yet to find their equilibrium. These objects were once thrown far away, pulled near, and finally trapped at the outer edge, where only silence and ice remain. If the cold classical group is the primordial memory of the solar system, then the hot group is the trace of upheaval. By studying their spectral composition, astronomers have found that the cold group has a darker red hue, a sign of complex organic compounds called tholins, formed when the faint sunlight broke down surface methane and nitrogen over billions of years. That red is the color of time, of the most ancient molecules. Meanwhile, the hot group shows a grayer or more neutral tone, possibly due to past collisions or temporary heating when drawn closer to the sun in the past. This difference tells a dual story. One part of the Kuiper belt has slept quietly since the beginning, while the other has lived through meteor showers and endless journeys before being ejected to the outskirts. Both coexist in cold balance, like two counterpoints in Neptune's symphony. Delving deeper, within this icy sea are special residents, binary systems. Hundreds of Kuiper objects do not travel alone, but exist in pairs, two bodies orbiting each other in a slow dance lasting centuries. Some pairs are nearly equal in size, like two dancers perfectly balanced in the void of space. The most famous pair is Pluto and Charon. Charon is not merely Pluto's satellite. It is large enough that the two actually orbit around a common point located outside Pluto's surface. This makes them a true binary system, a perfect gravitational bond between two solitary worlds. If you stood on Pluto's surface, Charon would not drift across the sky like Earth's moon, but remain suspended in a fixed position, for both are tidally locked to each other. The two worlds face each other motionless, rotating together in an eternal dance that never stops. Charon's surface is covered with cracks, remnants of a glacial past stretched by Pluto's gravity. Meanwhile, on Pluto, the vast nitrogen plains like Sputnik Planitia still reflect the distant light of the faint sun. Beneath this ice, there may exist a subsurface ocean, a body of liquid water warmed by the weak radioactive energy from the rocky core. If so, Pluto is not merely a fossil, but also the faintly beating heart of the distant solar system. Recent observations suggest that many other objects in the Kuiper belt may also harbor similar subsurface oceans. Beneath hundreds of kilometers of cold ice, there could be liquid water, ammonia, methane, mixtures not completely frozen, creating warm, deep layers. We have never set foot there, but the idea of lonely oceans in space sends shivers through the scientific community. In the farthest darkness, there could still exist places where chemistry continues, where life, even in its most primitive form, could persist. These discoveries turn the Kuiper Belt from a graveyard into a repository of potential. Instead of being mere remnants, it becomes a library preserving the formulas of life, hiding pages of planetary history that have never been opened. After flying past Pluto, New Horizons continued deeper to explore Arrokoth, a tiny snowman-shaped object 6.6 billion kilometers away. Arrokoth's surface is surprisingly smooth, with few impact craters and a deep red color, indicating it has remained largely unchanged since its formation. It is as if you are looking at one of the first bricks of the solar system's castle. Arrokoth is not just an object. It is a whisper from the past. Its two rounded lobes merge gently, almost embracing each other rather than colliding. This suggests that in the early era, planet formation was not a series of violent explosions, but a gentle, patient process, slow touches in the midst of dust and ice. This subtlety changes how we understand the birth of worlds. The universe can be violent, but life is born from the gentlest gestures. Thus, when we look at the Kuiper Belt, we do not just see the edge of the solar system, but also a mirror reflecting the journey of life, from chaos to structure, from collisions to resonance, from icy death to the potential for rebirth. Each object is a record, each orbit a line of poetry written in gravity. There, Neptune still conducts its silent symphony. Plutonos, Tutinos, dwarf planets, and countless smaller ice fragments all move to the invisible rhythm, orbit by orbit around the sun. And we, the tiny creatures on Earth, are merely a distant note echoing from that symphony, listening to the slow heartbeat of the universe. The Kuiper Belt, in its absolute silence, tells us the most important thing, that time never truly stops. It just moves more slowly in the colder places. Eris is regarded as the cold queen of the Kuiper Belt, a world where the weak sunlight is nothing more than a dim star in the distant sky. Temperatures there drop so low that everything, from methane gas to nitrogen, solidifies into ice. When the rare light reflects off Eris's surface, it glimmers like a diamond, forgotten in the darkness. The discovery of Eris in 2005 shook the astronomical community, forcing humanity to reconsider the question, what is a planet? It was Eris that sparked the debate, which led to Pluto losing its status as the 9th planet, and for the first time, the world recognized the concept of a dwarf planet. Interestingly, although Eris is smaller in size than Pluto, it has a greater mass, indicating that its material is much denser. This suggests that Eris may contain a rocky core occupying most of its volume, surrounded by a thick layer of hard ice. Its only satellite, Dysnomia, orbits Eris in a nearly circular path, like a loyal companion revolving around the Queen of Ice. The name Dysnomia, daughter of the Greek goddess of chaos Eris, is a symbolic reminder. Amid the chaos of definitions, science still finds order, just as Eris and its moon find a stable rhythm in the endless expanse of space. Further toward the edge of the solar system, Sedna drifts along an orbit so unusual that it remains an unsolved mystery. With an elongated orbit stretching nearly 1,000 astronomical units, Sedna takes more than 11,000 years to complete a single orbit around the Sun. At its farthest point, it is so distant that the Sun shines only as a bright star, smaller even than a full moon in Earth's sky. It is believed that Sedna may be a bridge between the Kuiper Belt and the Oort cloud, the farthest reaches of the solar system, where trillions of comets lie dormant in icy slumber. Sedna has a deep red color similar to Pluto, a hue indicating the richness of tholins, complex organic molecules formed under ultraviolet radiation. This red may be the result of billions of years of faint sunlight acting on its unshielded surface, triggering slow but persistent chemical reactions. If the Kuiper Belt is the boundary of the solar system, then Sedna is the doorway to the darkness of interstellar space. Among the kings and queens of this frozen realm, there are smaller but equally fascinating objects, Haumea, Makemake, and Quaoar. Haumea, an elongated dwarf planet, spins so fast that it is stretched into a rotating oval shape. A day on Haumea lasts only about 4 Earth hours, the fastest rotation among known dwarf planets. This rapid spin not only distorts its shape, but may also create a thin ring of broken ice fragments orbiting the planet like silver ribbons. Haumea has 2 small moons, Namaka and Hi'iaka. named after the two daughters of the Hawaiian goddess of fertility, Haumea. Together, the three form a cosmic family rich with mythological significance, where ancient mythology and modern exploration jointly tell the story of life and rebirth in ice. Haumea's surface strongly reflects light, showing that it is almost entirely covered by pure water ice, suggesting a past that may have experienced violent impacts, melting and recrystallizing its outer shell. Meanwhile, Makemake, another dwarf planet, smaller than Pluto, stands out for its reddish-orange color and bright appearance. Discovered in 2005, Makemake has an inclined orbit, residing in the distant cold region, yet still close enough that its atmosphere may appear temporarily when near the sun. Scientists believe that Makemake's surface contains layers of methane, ethane, and nitrogen ice, similar to Pluto, forming pale plains tinged with red from tholins. What makes Makemake particularly special is not only its appearance, but also the symbolic meaning of its name. In Rapa Nui mythology, Makemake is the creator god, the one who brought life to Easter Island. Perhaps this name also carries a metaphor. Amid the endless ice, seeds of creativity remain, telling the story of beginnings and existence. Further still, Quaoar, a dwarf planet named after the Tongva mythology of California, serves as a testament to the subtlety of gravity. Recently, astronomers discovered that Quaoar has a thin ring outside its Roche limit, something that should not occur, as material at that distance would normally coalesce into a satellite. This finding forces scientists to reconsider basic understandings of how planets and their rings form. Perhaps, even in the distant ice, the universe still retains a few secrets unwilling to be revealed. Taken as a whole, each dwarf planet in the Kuiper belt is a separate chapter in the frozen epic of the solar system. They tell of diversity, of past collisions, and of evolutionary journeys spanning billions of years. From Pluto with its soft nitrogen heart to cold Eris, spinning Haumea, and solitary Sedna in the darkness, all contribute to the somber yet majestic symphony of the cosmic frontier. For scientists, the Kuiper belt is not just a treasure trove of celestial relics. It is a gateway back to primordial times, a pristine repository of the materials that formed the planets. Each ice fragment, each orbit, each reflection of distant light is precious data, helping humanity better understand the origin of Earth itself. But beyond numbers and models, the Kuiper belt evokes a pure emotion, a sense of smallness before the vastness and respect for the silent persistence of the universe. In a place where a day lasts centuries of Earth time, and light is only a fragile breath, these celestial bodies continue to dance around the sun, slowly, steadily, like an eternal lullaby. If one could listen, one would hear that sound, the heartbeat of the ancient solar system, echoing through ice and snow, blending with the unceasing rotation of forgotten worlds. In near absolute silence, there is still rhythm. In the deepest darkness, there is still light. And in the boundless cold of the Kuiper belt, there remains the warmth of curiosity, of intellect, and of those who always look up in search. At the edge of the solar system, where sunlight is nothing more than a whisper, each icy dust grain in the Kuiper belt quietly tells the story of time. There, matter is nearly motionless. There are no violent storms like on Jupiter, nor boiling oceans like on Earth. There is only silence, bitter cold, and chemical reactions occurring so slowly that a human lifetime could not witness their change. Yet within this slowness lies the universe's greatest wonder, the infinite patience of nature. When the faint sunlight reaches, it awakens the dormant molecules on the ice surfaces. A small portion absorbs energy, vibrates, then breaks apart and recombines into new compounds. This process repeats over billions of years, bit by bit, forming a layer of tholins, complex organic compounds coating the surfaces of these celestial bodies. Under a telescope, this layer appears as a rust-red garment, giving distant icy worlds a strangely warm appearance. From afar, one might think these red hues symbolize life, and in a sense, that is not wrong. Even without living organisms, tholin-producing reactions are the first step in a chemical chain leading to complex organic molecules, the foundation of life. The Kuiper belt, therefore, can be seen as a natural laboratory where the universe experiments with the earliest formulas of existence. But not every world is cloaked in the same color. Some objects are silvery gray, cold as marble, where frequent collisions strip away their old surfaces. Others glimmer with a faint pink, as if time has painted them with a gentler hand. Each color, each degree of light reflection tells a story of age, of what has occurred there, collisions, radiation, or subtle temperature changes along orbits lasting centuries. When large dwarf planets like Pluto or Makemake move closer to the sun, their methane and nitrogen ice begins to sublimate, creating thin hazes and temporarily forming an atmosphere. As they recede, the gases condense, falling back like a returning snow. In this way, the entire world breathes, slowly but steadily, to the rhythm of its orbit spanning hundreds of years. It is a seasonal breath perceptible only through the patience of astronomers. Pluto is the most prominent example of this. When New Horizons passed by in 2015, humanity saw its surface for the first time not merely as a lifeless icy sphere, but as a vibrant world. Nitrogen plains, towering water ice mountains thousands of meters high, small methane dunes, all prove that even in the coldest places, nature still operates. The cold does not kill activity, it only slows its pace to a different frequency, slower yet more enduring. And there, at the Tomball heart, the heart-shaped plane on Pluto's surface, we see something science sometimes forgets: beauty. Not the sparkling beauty of light, but the beauty arising from stillness, from random forms that nature inadvertently creates. That image sent back to Earth was not merely scientific data. It was a mirror reflecting the human heart. Even billions of kilometers away, people still find emotion, still recognize themselves in those frozen lands. Meanwhile, at the far edge of the Kuiper belt, smaller objects continue to rotate silently. They may never be explored, may never be named, but they are remnants of the solar system's formation process. If the large planets are completed works, then these small ice blocks are unfinished drafts, sentences left incomplete in the ancient journal of the universe. Astonishingly, though they exist in such distant and frigid places, they still affect Earth. Whenever a comet from that region is perturbed and plunges into the inner solar system, it carries primitive material, ice and dust older than our planets. When the comet disintegrates near the sun, it deposits elements and compounds that once formed water, atmosphere, and perhaps even life on Earth. The Kuiper belt, therefore, is not merely a remnant, it is the distant source of our very being. From a broader perspective, one can view this region as a somber symphony between light and darkness. Sunlight still filters through each ice crystal, only to reflect back, faint but persistent. Each photon of light takes more than 6 hours to reach this place, and then another 6 hours to return to human eyes. That means every image we see is a memory, light from the past, reflected by worlds still slowly turning in the present. When astronomers observe the Kuiper belt, they study not only physics or chemistry, they are witnessing the patience of the universe itself. For in a place where all movement is so slow it is almost still, only time flows without interruption. And it is time, not fire or water, that is the greatest artist here. If there is a lesson the Kuiper belt imparts to us, it is perhaps a lesson about existing in stillness. Without noise, without brilliant light, these worlds persist orbiting the sun, merely to demonstrate that beauty can be found even in darkness. Each dwarf planet, each ice block, each dust grain in that land is proof of a simple yet profound truth: the universe never repeats itself. Even with the same materials, the results are always different. And perhaps, in that very difference, the universe is telling the story of itself, a story without end, written in light, ice, and time. In the farthest reaches of the solar system, where darkness seems to become a living entity, all motion occurs to the rhythm of the universe. On dwarf planets and small bodies in the Kuiper belt, time does not flow as we understand it. It spreads slowly, softly, and so long that each moment seems to stretch for centuries. A rare solar wind, a solitary photon from the sun, or a minor collision with a distant meteoroid can leave marks lasting billions of years, tell us inscribing delicate layers of memory onto icy surfaces, like pages of an ancient journal. The surfaces of these objects come alive in ways humans rarely experience. Frozen nitrogen and methane, once merely inert compounds, suddenly breathe to the slow rhythm of their orbits. As the celestial bodies approach the sun, the ice sublimates, forming a thin layer of gas that spreads before freezing again in the distance. This process resembles a delicate dance. The atmosphere inhales and exhales. Layers of vapor thin, accumulate, dissipate, and then return. It is a breath no living creature can perceive directly. Yet through telescopes and sensors, humans begin to understand it as nature's silent language. Even the faint sunlight, after traveling for hours from the sun, becomes a subtle instrument in this chemical symphony. When photons touch the icy surface, they break old bonds, rearrange molecules, and create tholins, red and brown organic films, casting a warm hue amidst the piercing cold. Classical objects, such as Pluto or Eris, bear this time. The darkened surface testifies to long existence, while bright silver regions reflect recent changes, where fresh ice has flowed or gases have sublimated back into ice. Each dwarf planet, each small ice block is a living library. A layer of ice mere centimeters thick can preserve stories spanning millions of years, recounting rare collisions, the constant irradiation of cosmic rays, and the faint but persistent influence of sunlight. Every crack, every color patch is the universe's memory, recording time in ways humans can scarcely imagine. Whereas on Earth, everything is continuously eroded, worn, or renewed. In the Kuiper Belt, events are preserved almost intact, like a frozen eternal museum. The isolation of these celestial bodies also produces strange variations in color and reflectivity. Some are covered with nearly pure water ice, reflecting almost all light, appearing pale and cold. Others, enriched with altered nitrogen or methane, are tinged red or deep brown. The tholin layer creates bright red, symbolizing long-term aging and weathering, while fresh ice produces silver hues, representing recent changes. All these shades coexist, forming a rich, vivid spectrum, even if only on icy worlds tens of billions of kilometers from the sun. Cold is not merely the absence of heat. It is a method of preservation, a conservation mechanism nature bestows upon the outermost solar system. At temperatures around -200 degrees Celsius, nitrogen, methane, and carbon monoxide freeze into ice, forming stable but brittle structures. Water ice becomes hard as concrete, solid as cosmic stone. Even when sunlight falls, the surface changes only subtly through slow sublimation or thin layer movement. What occurs on these surfaces is a metaphor for the rhythm of time, so slow that humans can observe change only over millennia. Extended orbits, sometimes taking hundreds of years for a single revolution, stretch all seasons into eternity. On Pluto, half the world can remain in darkness for centuries before the sun returns to kiss it with faint light. Temperatures fluctuate slightly, the thin atmosphere freezes entirely, and frost layers cover the icy terrain, marking moments in a prolonged cycle observable only from afar. Smaller objects, unexplored ice blocks, continue to spin silently, like dust particles in a slow whirl of time. Every impact crater, each thick ice layer, each minor chemical reaction testifies to a history continuously accumulating, recording the evolutionary picture of the solar system in a deep freeze. No storms, no waves, no winds erase traces. Only enduring silence remains. It is this silence that creates an indescribable beauty, a beauty of compressed time, of a universe preserving memory without words. And in all of this, sunlight remains the main actor, though weak and slow. It is no longer brilliant, yet it is sufficient to produce energy, to drive the cycle of sublimation and freezing, to illuminate the colors of ice, tholins, and even the potential chemical life within organic molecules. Those weary photons, after hours of travel, become invisible artists, slowly painting delicate hues across the surfaces of dwarf planets and ice blocks, extended over time. The Kuiper Belt, therefore, is not merely an icy ring. It is a living museum of time, where everything slows to endure, where each photon, each ice particle, each chemical molecule is a page in the universe's journal. And when we look upon the pale colors, the red, white, and brown regions, we see not just matter, we see patience, persistence, and the pure beauty of a solar system quietly telling its own story. In the icy expanse of the Kuiper Belt, time and distance converge to create a world where every encounter is shaped by infinite patience. Two small celestial bodies drift close to each other, neither hurried nor swept away by violent forces, but gradually approaching like slow, deliberate breaths. The faint sunlight, after hours of journeying across the vast emptiness, is only enough to glimmer off the ice particles on their surfaces, softly illuminating their orbits. Over centuries, the small but persistent gravitational pull draws them together, forming a strong yet gentle bond, unlike the catastrophic collisions that occur near the rocky planets in the inner solar system. Binary star systems in the Kuiper belt are vivid evidence of how matter in the early stages can self-organize. A pair like Arakoth, formed from two blocks of ice and sediment, appears as a masterpiece of nature's subtlety. A large block and a smaller block connected by a narrow neck with smooth surfaces and few impacts, resembling a couple embracing in a slow cosmic dance. This is not the result of violent collisions, but of tiny gravitational forces gradually pulling them together over millions of years and thousands of orbital cycles. This merger is a dance of time, where the patience of the universe far exceeds any human measure. Each binary system tells a story of enduring existence. Slow orbits and weak gravity allow the two bodies to maintain their connection without tearing each other apart, avoiding interference from larger planets. Even nearly equal-sized pairs can drift in the cold expanse for billions of years, revolving around each other gently like an endless circle. Some systems maintain a safe distance, like old friends staying close without intruding into each other's lives. Others gradually draw closer, spiraling inward, and eventually merge into contact binaries. Arakoth is a prime example, where layers of ice and sediment combine into a unified body, yet retain the soft, gentle traces of the merging process. The colors of these binary systems tell their own stories. Tholins and organic compounds create reddish-brown coatings on the surface, signaling prolonged exposure to cosmic radiation. Fresh ice layers glisten in silvery white, evidence of recent changes when gases sublime and refreeze. The combination of classical red and pure silvery light creates a vivid temporal painting that only the most patient photons from the sun can trace. By studying these shades, astronomers discern not only chemical composition, but also the long history of binary systems, the slow steps nature has taken to produce these unique shapes. Binary systems in the Kuiper belt also serve as natural laboratories for gravity and orbital mechanics. When two bodies come close enough, their mutual attraction can overcome the weak influence of the sun, allowing them to orbit each other indefinitely. Without strong collisions or disturbances from larger bodies, they can maintain stable connections for billions of years. These observations provide direct evidence how the first planets and satellites formed. From small, pure matter particles through subtle, gentle pairing steps, before heat, gravitational chaos, and violent collisions became dominant forces closer to the sun. Another intriguing aspect is the preservation of primordial material. At extremely low temperatures, chemical reactions nearly cease entirely. Molecules that would decay in seconds on Earth remain intact for millions of years. Nitrogen, methane, carbon monoxide, and organic compounds are preserved as if in a gigantic natural freezer. This allows scientists to observe the ice fossils of the solar system, learning about the conditions and composition of primordial matter over 4 billion years ago. Each binary system is a natural archive, not only of structure and shape, but also of chemistry, where time seems compressed, preserving the universe's earliest moments. The cold expanse of the Kuiper belt also demonstrates the gentleness of gravity. Collisions are not violent like in the inner solar system. Instead, small bodies touch, draw close, and merge, like couples exchanging gentle embraces in the infinite space. Contact binaries, spiral orbits, and intact ice blocks all tell a story of slow, peaceful, and astonishing existence. No wind, no rain, no seas. Only cold and time combine to create graceful, enduring structures, nearly immutable over billions of years. Ultimately, binary systems in the Kuiper belt remind us that the solar system is not just a collection of large and dwarf planets, but also a delicate network of small relationships, slow progressions of matter, and moments frozen in time. From the faint sunlight, from near absolute zero temperatures, from the slow drift of small celestial bodies, the universe has created enduring bonds, intricate shapes, and pristine treasures, marking a planetary formation process that no chaos can destroy. Today, when astronomers observe Arakoth or other binaries, they see not merely a cold object, but a living story of how the universe operates at a pace that humans can scarcely imagine. The delicate connections, the serene orbits, the pristine ice layers, and the Tholin red all combine to narrate the solar system's beginning. A symphony performed with faint light, cold ice, gentle gravity, and infinite patience. In the Kuiper belt, each layer of ice and sediment accumulated since the early days of the solar system serves as a living record of time. Slow, gentle collisions, rather than destroying, act like an artist's hand, meticulously sculpting the landscape to the universe's deliberate rhythm. A small celestial body striking a block of ice does not release chaotic energy. Instead, the force spreads, bends, and compresses. Each grain of ice, each molecule of nitrogen and methane responds with a strange plasticity, enough to alter the surface without erasing the history preserved in every layer of ice. This system resembles a slow-motion film. Every movement, every impact occurs at a speed imperceptible to the naked eye, yet with billions of years of accumulation, these subtle changes form a meaningful landscape. The porosity and softness of these celestial bodies play a crucial role in preserving the imprints of the past. Their low mass and hollow structure allow them to absorb impacts without cracking. On the surface of Pluto and other dwarf planets, the New Horizons spacecraft recorded round craters, smooth surfaces, and soft rims, in stark contrast to the sharp craters on the Moon or Mars. This surface layer is evidence that weak gravity and low orbital speed create a world where even collisions occur with the courtesy of a slow gesture, rather than the ruthlessness typical of regions nearer the Sun. Upon closer inspection, these craters reveal many layers of Kuiper belt history. A small, shallow, faint crater may be the trace of a light impact from several 100 million years ago, while a deeper crater with smooth edges may expose layers of ice and sediment never touched by sunlight or cosmic radiation. These layers contain complex organic compounds, even precursors of molecules essential for life, preserved intact thanks to the cold that halts chemical reactions. Time here, slow and persistent, acts as a patient guardian, safeguarding delicate details and allowing modern scientists to understand the early chemical landscape of the solar system. Methane and nitrogen ice do more than preserve. They also move subtly over millennia. Under gravitational influence, a layer of ice can creep like paste, filling depressions, softening sharp edges, and creating smooth surfaces. This silent restructuring is unlike anything on the rocky planets closer to the Sun. No volcanoes, no wind, no rain, just the gradual motion of cold matter, grain by grain, in an eternal dance. Every movement, no matter how small, is a note in the cosmic symphony of time, a testament that even in silence, evolution continues. Larger, rarer impacts also follow the logic of stillness. When two massive bodies meet, rather than shattering into countless fragments, they may disperse smaller pieces, forming collision families, groups of small objects sharing the same orbit and chemical composition, direct descendants of an ancient encounter. The dwarf planet Haumea is a prime example. The surrounding debris not only orbits the Sun, but also bears the pristine traces of a common origin. These systems demonstrate that even in silence, creation accompanies destruction. But here, destruction is subtle, elegant, and non-destructive. Craters, fine dust, and deposited ice grains all serve as reminders that time in the Kuiper belt is unlike time on Earth. A crater here is not merely the result of a collision, it is a repository of history, a gateway into a distant timeline. Through layers of ice, astronomers can revisit the earliest moments of the solar system. Small celestial bodies, slowly orbiting each other, merging gently, colliding lightly, and experiencing billions of years together. This system also illustrates how weak gravity and low temperatures cooperate to maintain stability. Companion bodies can coexist indefinitely, drifting through millennia in absolute tranquility, sometimes merging into contact binaries like Arokoth, sometimes maintaining distance, their rhythm shaped by a delicate balance of collisions, gravity, and time. It is this patience and slowness that turns binary systems into living archives of the past. They tell the story of how the first planets formed from small, pure matter particles before heat, violent gravity, and strong collisions dominated. Ultimately, the Kuiper belt landscape is a symphony of stillness. Craters, layers of methane ice, reddish-brown tholins, and companion bodies are not merely physical structures but symbols of the universe's patience. Every slow movement, every gentle impact, and every new layer of ice is a beat in the dance of time. Even in absolute silence, the universe continues to operate, create, preserve, and recount its own history. The Kuiper belt, therefore, is not a secluded quiet space but a living museum, where time, gravity, and matter intertwine to portray a story of subtlety, endurance, and the wonder of the solar system.